Hey everyone, in this video I'm going to explain the solution for a Leetcode question called Game of Life, which is used by some big tech companies, and also at the same time I'm going to go through the steps we should follow in a real coding interview. So let's get started. So in the real coding interview, the first step is always try to understand the question, and if there is any if there's any ambiguous part, feel free to bring up the question, and at the same time think about some edge cases that can potentially break the general solution in the next step. So let's go through this question briefly. So according to the Wikipedia, the game of life, also known simply as life, is a cellular automaton devised by the British mathematician whatever. So the board is made up of an m by n grade of cells, where each cell has an initial state life, which is represented by 1 and dead represented by 0. So each cell interacts with its 8 neighbors, and there are 4 coordinations. So for a live cell, if there are fewer than 2 neighbors, fewer than 2 live neighbors, then it will die. If there are more than 3 live neighbors, it will die. If there are 2 or 3 live neighbors, then it will continue to live. For the dead cell, when there are exactly 3 live neighbors, then it will become a live cell. So this is a example, like a transition example. So the question is, the next state is created by applying the above rule simultaneously to every cell in the current state. So we are going to try to figure out the next state for the grade given the current grade. So this is an example. So let's see some constraints. So it says that the given board is not going to be empty, so we don't need to worry about that kind of edge case. And also there won't be any illegal inputs because each of the cell is going to be either 0 or 1. So, and there is some follow-up question asking, is it possible to do it in place? The answer is yes. So this is exactly what our solution is about. So the solution is the runtime is OM by N, and there is no extra space used in this solution. So the solution is, in general, we use 2 additional integers to represent new states. So integer 2 means in the next state it is going to turn from dead to live, and for integer 3 it means currently it is live, but next state for it is dead. So after we find the solution, then we do some coding work on top of the ideas about the solution. So it is quite simple after we figure out how we do it in place by introducing extra state. So in here we introduce an helper function, which is to count how many live neighbors are there for given a corresponding cell. So there are 3 parameters passed into it: the board, the row, and the column. So we are going to return how many live neighbors are there for given the current state, given the current row and the current column. So within the major function, every time we just call the helper function to count the left neighbors and follow the rules to update the corresponding board to the new state if possible. And after that, we have a new board. We need to turn the intermediate states, which are 2 and 3, into 0 and 1, and after the translation, the board is going to be the next state. So that's essentially how we solve this problem. So after you find the solution and you discuss with your interviewer about the solution, you do some coding work, take care about the correctness, the readability, and also don't be too slow in the coding part. And after you're done with coding, it's not a time to call it succeed. You still need to do some testing to introduce some test cases to inspect if there is any bug within the code. So that's it for this question. So if you have any question about the puzzle or about the code, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.